Hi, my name is Clint Cooley. I'm the president of Circuitco Electronics here in Richardson, Texas. We're a contract manufacturer for printed circuit board assembly. Today, I'm happy to introduce to you the Panda board. This is a new EVM from Texas Instruments showcasing the TI OMAP 4430 dual-core processor. Today, I'm going to take you on a tour of how this board is produced here at Circuitco.
Stage one in the process is printing the board. Here you see the operator loading the deck printer using water-soluble paste, lead-free. All pads on the board are pasted. Stage two is pick and place. Here the operator is loading the SMT machine. The OMAP processor is a 0.4 millimeter pitch. Also, there's many 0201 components on the board. These machines place about 15,000 parts per minute, and we can flux the POP, which is the memory for the processor, directly from the machine. Stage three is reflow. The operator loads the board in to the reflow oven after SMT is complete. The maximum temperature for the oven is 260 degrees C. After reflow, the board goes through a wash process to clean. After all surface mount components are put on the board, basically what we do here is we're putting all the through-hole parts in. There's a few connectors that we put in, but not that many through-hole parts on the Panda board. Also during this stage is a precursor to inspection, where if the operator sees maybe a capacitor that's tombstoned or something, or a discrete component, something like that, they'll also touch it up. Very little touch-up is required after SMT. As part of the inspection process, we utilize the Testronics 505 AOI machine. AOI stands for Automatic Optical Inspection. After all the components are on the board and everything's soldered, what we do is we run it through this machine. It will automatically check for any misaligned components, any parts that may be oriented improperly. It'll even check down to the solder joint level to make sure the solder reflow and any kind of hand soldering that we did was done properly. In addition to AOI, we also do a Class 3 visual inspection. Visually inspecting, we're looking for anything that AOI might have missed, which is very few items, and also we're again confirming that the reflow, and also looking visually at any ball grid arrays, the outer perimeter of the balls, to make sure that the OMAP and any other ball grid array on the board, a device like that, seated properly and the balls have collapsed. After the boards are optically inspected, they come over to the burn-in racks. These burn-in, basically what we're doing is we're doing a run-in test of sorts. It's checking memory function. The software is not totally loaded on the board yet, but again, we can confirm that the boards will stay powered on for 24 hours without anything failing, and also do a cursory memory test during this phase as well. Basically, the burn-in rack is set up with just a power supply, and we plug the boards in to the outlet here, and again, we let them run for 24 hours. Each board is 100% functionally tested prior to shipping out to the customer. This is Ralph Bonaparte. He's the engineering manager here at Circuitco. Basically, all interfaces on the Panda are tested. Ralph, specifically, what are some of the major parts that we're testing here in the functional test?
It's a DVI, HDMI, USB host, USB LAN, audio in, audio out, and WLAN and
Thank you. And that's how the Panda board is produced. Thank you very much for your time, and I hope this tour has been informative for you. If you have questions, or if I can be of any help to you, please do not hesitate to visit my website at www.circuitco.com. Thank you.